Welcome to ground control. I have my wing completed. It's fully assembled. I have it programmed into the transmitter. Isn't that a nice looking wing? So I wanted to go over some information on this wing before the maiden launch in case some of you have ordered this. Maybe you've already received it. Maybe you're getting ready to launch it. And this was provided courtesy of Banggood. I want to thank them much for sending this item for review. Now, wings are probably, I would say, one of the most maneuverable, one of the most aerobatic fixed-wing aircraft I've flown. And they have an extremely wide flight envelope. You can fly very fast and you can fly very slow with them because the entire airframe creates lift. So on my initial setup for this, and I wanted you to see this. Can you see how much down angle there is in that motor to push the nose down? So I would say on the maiden launch, or when you launch this, I would say you want to be fairly judicious in the amount of throttle that you use when you launch it. So I'm just going to power up the throttle to the point where it feels like it wants to pull out of my hand, and that is the throttle that I'm going to launch it with. Now when I get this all tuned up and create my setup file, I'll create a setup file and publish it on our Facebook page. If you want to take a look at how what my setup is, with the linkage, and I will also have the hand launch throttle setting in there. And I will also create and export my OpenTX model file for download if you guys want to import it in. On my initial setup, because wings rotate very well in both axes, in the roll and especially in the pitch axis, I'm going to set mine up initially for the maiden launch with about 6 millimeters of movement on the ailerons on the elevator, 6 millimeters up, 6 millimeters down, with a ton of expo, about 60% expo on both of those. I would rather have too little movement in the control surfaces on the maiden launch than too much, because especially with the wing, it will be it'll be too abrupt in its movements, which will make it really twitchy and harder to control. So I would rather start off low and then increase it when I need to, if I need to. For my final setup on the assembly on this, the plug and play kit, which is what it is, a plug and play kit, is probably the easiest to assemble plug and play kit that I have put together so far. On your initial setup, I already told you what my movement's going to be, but you want to make sure that your control surfaces are level with the trailing edge of the wing. And one thing I noticed is over here close to where where the wing meets the fuselage, there's a little more curvature right here in the trailing edge than there is on the outside trailing edge of the wing. So I set my control surfaces up neutral with that outer edge out there, because if you have a little positive setup in your control surfaces on launch or on flight, the wing is going to want to kind of zoom on you when you throttle up. So that's where I'm setting my initial control surfaces. All right, so, and I'm going to have a neutral balance on the CG. The CG is marked. There's a couple of raised sections right here. So I'm going to have it set up to where it's completely flat when I balance it at that point. There's a lot of room inside the fuselage for all different kinds and sizes of batteries that you want to put in it. The recommended battery, and it says 100 grams of LiPo on a 4S LiPo is the recommended, and I do think that that is the minimum amount of weight, which I think is why they specified 100 grams. I think 100 grams is the minimum amount of weight that you're going to need on your LiPo in order to get a neutral balance on the specified CG. I tried several different LiPos in it the other day, 3S and 4S, and that's what I found, was that you're going to need a minimum of 100 grams of LiPo weight to get the CG on on this wing without adding any ballast weight on the nose. So be aware of that. Trimming of the motor wires. I did not trim my motor wires. I put very short leads on my ESC. I put 2mm bullets on the ESC and the motor connections. The motor leads are very long. I didn't trim them down, but if I had to do it over again, because the motor leads were so long in this, and the ESC is so close to the motor, that I ended up having to loop those wires twice around to get them inside the ESC compartment. And I think that if you trim those motor wires back to just the length that you need to be able to connect it to the ESC, you could probably save about 3 grams of weight on the back end of this airframe, which may make it easier to get a lipo that's slightly under 100 grams, be able to get your CG if you reduce that tail weight like that. If I had to do it over again, I would trim those motor wires way back to just the length that I needed to connect it to the ESC and save 3 grams of weight back there on the tail. So something to think about. There are channel leads for your antenna wires. If you have a receiver, let me open this up to show you. If you have a receiver, and this is just a standard 6-channel receiver, but it's a diversity antennas, and the antennas are long antennas. So if you have a receiver that has a long antenna or long antennas, there are channels cut in the top of the fuselage here so that you can route them underneath the canopy cover, and then there are also channels cut on the inside of the vertical stabilizers where you can route your antennas. And so that's what I did. I routed my antennas through there, and then just put strips of packing tape in there to hold them in place. And that worked out really well. You can see you got tons of room inside there. My 4S lipo that I use to get my CG is, it's probably about 10, I would say about 10 millimeters back from the very forward section of the fuselage, and I was able to get my neutral balance on the CG with that lipo. It's a 4S 1050 95C that weighs 120 grams. The 3S lipo that I'm going to test it with is a 3S 1300 milliamp hour lipo 30C. It weighs 105 grams, and so I had to push that one as far forward as I could and still get the canopy, the front of the canopy closed on it, in order to get the neutral balance on the CG. That was a 105 gram lipo. So that's why I wanted to talk about trimming those wires down on the motor, save a little bit of weight there, and then you could probably get away with something slightly under 100 gram lipo pushed all the way forward to get your CG balance. But plenty of room inside that fuselage. If you want to use a larger battery than what I'm using, you'd definitely be able to do that. Okay, so the weight of my completed airframe without a lipo in it, with all the electronics in, just as you see it right now, was 206.2 grams. The 3S lipo that I'm going to be using with it, as I stated, weighs 105 grams. So my all-up weight with that 3S lipo is going to be 311.2 grams, below the recommended 320 gram weight. And with the 4S lipo, which weighs 120 grams, it puts the all-up weight at 326.2 grams. Not bad. I mean, I'm only 6.2 grams over the 320 gram recommended, and I believe it's set up to 420 grams. So it's going to be a pretty lightweight wing with the way that I'm going to have it set up. I had my doubts about this little tiny motor, because it is tiny. It is a 2004 2700 kV motor, and it is spinning a 5125 T-mount prop. When I first got this kit and I saw this motor and I saw the prop that they were putting on it, my immediate thoughts were, this motor is not going to be able to spin this prop fast enough, especially on a 4S lipo, to produce enough power. I was already contemplating replacing that 5125 prop with a 4025 prop, because I just knew this motor was not going to be able to spin that prop fast enough on a 4S LiPo. Well, I'm happy to report that I was pleasantly surprised in the amount of power that this motor and prop produce. I couldn't believe it. I took one of my 4S LiPos that I'm going to be flying it with, and it was a storage level charge, 3.8 volts per cell. So I put it in there, I bound it up, I held it vertical, and I slowly pushed the throttle all the way up to 100%, and this thing was going to go vertical with no problem whatsoever. This wing was going to have unlimited vertical with the 4S LiPo at storage level, 3.8 volts per cell. So this on a 4S is going to be a little rocket ship. And then I put a fully charged 3S LiPo in it. I did the same thing, held it vertical and powered it up, and it was going to go vertical with the 3S LiPo. Now, that was a fully charged 3S LiPo. I don't know if it will have unlimited vertical on a 3S LiPo. I know it's going to have unlimited vertical on a 4S LiPo. But if it doesn't have unlimited vertical on a 3S LiPo, it is going to push vertical very, very well. So I don't think you're going to have any problems flying this wing with a 3S or a 4S LiPo at all. When I take it out and do the initial maiden launch of it, if everything goes well, I'm going to do the next review video is going to be with just a couple of 4S LiPos to see what it does, and then the next review video I put out, I'm going to take it out and put a couple of 3S LiPos through it. So I want to see what it's going to be like on a 4S LiPo, which is what it recommends. So that's what I'm going to do first, and then put a 3S LiPo in it and see what it does with a 3S LiPo. So, but I think it is going to have plenty of power. Whether you're going to use a 3S or a 4S, on a 4S, it is going to be a little rocket ship. I don't have any doubt after testing that. Okay, so then I charged up both batteries, the 3S and the 4S LiPos that I'm going to be using. I put it on a load meter. I wish I had time to take this motor off and put it on a thrust stand so I could actually measure the thrust and not just the amp draw. Maybe after the first of the year I'll have a chance to do that. But so I wanted to give you these numbers. Okay, so on a 3S LiPo, at 50% throttle it was pulling 5.3 amps. At full throttle it was pulling 15.5 amps. On a 4S LiPo it was pulling 6.8 amps at 50% throttle and 21.9 amps at 100% throttle. So it looks like it's not only going to produce a ton of power, but it's also going to be fairly efficient for that size motor. I couldn't believe it. I really thought one of the reasons I was thinking of replacing this 5125 prop with a 4025 prop was I figured that this motor would not have enough torque on a 4S to prevent it from pulling over 30 amps at full throttle. That's what I was thinking. Not only was it not going to produce enough thrust, but I thought it was going to be pulling well over 30 amps, 2700 kV little motor like that. I was surprised that at full throttle it was only pulling 21.9 amps. So you've got a lot of headroom on that 30 amp ESC, which totally surprised me. I did not expect that. But I definitely want to put this motor on a thrust stand and get the thrust numbers off of it and see what the gram per watt efficiency is, because I might want to use this motor in some other projects. But I was completely impressed with it. So I wanted you guys to be aware of that, you know, because I'm sure a lot of you, like me, looked at that motor and looked at that prop and thought there's no way that motor and that prop are going to be able to push that wing. But it's definitely going to push it, and it's going to push it fast. Okay, so I had just a couple of complaints, and they're minor ones. But there was no ESC manual in the documentation, and my motor has the brake on. So I got online yesterday and I searched for a manual for the ESC and I could not find one. So I'm going to have to go through my other ESC documentation and see if the beep codes for those will work with this ESC, at least so that I can get the brake off of it. I want mine to freewheel. I don't want the brake on. So I'm going to see if I can get that done. If I'm successful in doing that, then I will post that information on our Facebook page. And the motor. I love this little motor and this prop combination. I think they did a really good job with thrust and efficiency with this power system. My only complaint with the motor is it only has 2 threaded holes on the top of the bell housing to mount the prop instead of the customary 4. I hope in their next production run, hint, 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 you put 4 threaded holes in the top of this bell housing instead of just 2. Because I have received motors before that had a bad thread in one of those holes. And I was able, of course, if it's got 4 holes, you're able to rotate the prop 90 degrees, mount it on the motor, you're back in business. At one time, because the bell housings are made of aluminum and aluminum is soft, and the bolts are made out of steel, which is hard, I accidentally over-tightened one time and stripped the aluminum hole, the threads in the aluminum hole. And again, I was able to take the bolts out, rotate the prop 90 degrees and mount it in there just fine. I was ready to go again. But with only 2 holes, you're not going to have an option of doing that. So please tap 4 holes in the top of the bell housing on your next production run instead of 2. That was my only complaint about the motor and about the ESC. I don't know why it came. I don't know why by default it has the brake on, but I want to try and get it set to where the brake is off and it freewheels. But anyway, I wanted to make you guys aware of that information. It's a fantastic looking wing. It's well made. Everything fits together extremely well. The assembly was a piece of cake. If you follow those tips I gave you on trimming the motor wires and stuff, you'll be able to shave off 3 grams and be able to get your ESC or get your CG with perhaps a lipo that's slightly under 100 grams. So stay tuned. As soon as the wind, slows down a bit here, I'll be able to take it out and launch it. I'm hoping for a window of opportunity tomorrow morning. So watch for the maiden launch of this wing on 4S. I think it's going to be scary fast. So thanks for watching, and I will see you in the air.